Okay, so for part C, it's hitting the ground and it's managing to sink in a little way until it stops. So for us to work out the force, the resistance force of the ground, first of all, we need to know how much it's decelerating and use F equals ma. And then to find the deceleration, well, we know it comes to rest. We know this distance is 2.5 centimeters. Watch out because that's 0.025 meters. But what would be really useful to get acceleration would be to know what speed it's going when it hits the ground. So to do that, we need to go back to our original bit from part B. So it started 1.5 meters above the ground. It went up at 22.4 meters per second, and then back down to the earth. So S was minus 1.5, U was 22.4, A is always minus 9.8 for these, and then we need V. So that will be V squared equals U squared plus 2AS. So minus times minus is going to be a plus. So let's put that in a calculator and then square root. So 22.4 squared plus 2 times 1.5 times 9.8 is 531.16, and then square rooting that. It's not anything nice, so I'm just going to leave this square root. Okay, so that's the speed it hits the ground at, so that's the U for over here. So let's do the deceleration. So we've got V squared equals, sorry, let's do the CVAT first. Oh, no, that's fine. So I want V squared equals U squared plus 2AS. So V squared is 0. U squared will be 531.16 plus 2 times A times 0.025. So minus 531.16 equals 0.05A. So A is 106.23.2 meters per second. It's negative because it's decelerating. We'll worry. Don't really need that at the moment. I just need to know what the acceleration is. I'm not going to worry about signs for a second. So in order to us to find the force, we need to draw a force diagram. So I've got the ball, and its weight is going to be mass times gravity, so 0.6 g. The resistance force we need to find, and the acceleration is up 106.23.2, or if you like, down is negative. If you did it down, it would be negative that. So I'm doing it's up at this acceleration. So when I do my F equals ma, this and this are going to have the same sign. This is going to have opposite signs. So F equals mass times acceleration. Just plug that in a calculator. So that's 6379.8, and it asks us to round it to 3 significant figures. So that's 6380 newtons to 3 significant figures. Now the velocity time graph, it started off with velocity 22.4 meters per second. When it hit the ground, it was going downwards at route of 531.16 meters per second. We worked that out in the previous part. Which is 23.04. And that was going down, so it'd be negative. And we found the time it takes to hit the floor, which is 4.64 seconds. We know that the gradient is the acceleration, and we know the acceleration is 9.8 meters per second squared, so we can work out what this is. So your rise over your run, I'm just doing this triangle and finding the gradient. The rise over the run has to be 9.8, and the rise was 22.4. And I want to know this time. So just rearranging that. So that time is 2.29 seconds. And then the last part is just about air resistance. So yeah, if you included air resistance into it.